Okay, we're going to look at Chapter 19, Confidence Intervals for Proportions. I just want to remind you that, your book has these 4 examples and then also has step-by-step examples. Look through those. This is a relatively short chapter, and then just summaries in blue, terms, etc. So this is a relatively brief chapter, and I think I can instruct it with one kind of interesting example. So I found Pew Research is great. They have all kinds of interesting information. It's talking about what do people think should be top priorities, and it says here that 76% of the people surveyed believe that terrorism, keeping us safe from terrorism, should be a top priority for Congress and the president. Curiously, immigration is way down here at 43%. Poor and needy is way up here at 56%. Race relations, 56%. So kind of interesting when we look at it. Look at what people think Congress and the president should be working on. So I want to look at this 76%, but in order for us to analyze this, the great thing about Pew Research is they're very scientific and they are nonpartisan. I'm going to go to their methodology, and it says here that most of the analysis is based on telephone interviews when they interviewed 1,502 adults, 18 years or older, living in 50 U.S. states, yada yada, landlines, cell phones, etc. So it's a bit more complicated than what I'm going to present because I think not everyone answered every question, but we are going to use the sample size as 1,502. Okay. So this is really about how do we take a sample and then report something from it. How does Pew Research say 76% of Americans think that terrorism should be a top priority? Well, they construct that confidence interval. Oh, I forgot to tell you that somewhere, shoot. Oh, here we go. At the bottom of methodology, it says the following table shows the unweighted sample sizes and the error attributable to sampling that would be expected at the 95% level of confidence. So yeah, what is this all about? And again, it's a little more complicated than I'm going to present it here, but this is introductory statistics. So how do we construct a confidence interval? We find a sample proportion, and then we figure out a margin of error, plus or minus so many percentage points. And how do we get that margin of error? We take a z-star and multiply it by our standard error of our sample. So what is all this? Well, z-star is a critical value. So for a 95% confidence interval, we think of z 95% being 2 standard deviations away. Technically, it's only 1.96. If we only wanted to capture 90% of the curve, we would only need to go out 1.645 standard deviations. And what is this SE? What would happen is standard deviation? Well, the problem is that since we're using sample proportions, we actually don't know. We don't have an expected proportion value. So we have to use our sample proportion, and therefore it's called a standard error, but a better term might be a standard estimate. But anyway, we call it standard error because there's some error in it because we're using the sample proportion. We don't actually know the true proportion. And because we're using a z-score and we have a single proportion, this is called a one proportion z interval. And again, before we can go ahead, this is all based on the fact that we think this sampling distribution will be normal. Our assumptions and conditions are the same. Do we think that the data is independent of each other? We check that by saying, was it a random sample and did we sample less than 10%? Certainly 1,502 people is less than 10% of the population of adults even. And is our sample size big enough? Would we expect at least 10 successes, and would we expect at least 10 failures? All right, so let's see what Pew did. And this isn't exactly what they did. Oops. I had my numbers wrong. So they went out and sampled, or they called people, and they found out that 76% think that terrorism should be a top priority. And we want to figure out, remember, we don't know what the true proportion is, but we know that 95% of samples will fall within 2 standard deviations of the true proportion. So we construct a 95% confident interval. So we take our sample proportion, and we're going to add or subtract to it, plus or minus. Not quite 2, it's only 1.96 really. I have the 2 up here to capture 95%. And again, that's the number of standard deviations away. So we have to multiply by the value of the standard deviation, or in this case, the standard error, because we're using our sample proportions. So we get a proportion of 76%. We're going to stretch it out almost 2 standard deviations, in this case, standard error. Our standard error is we found a 76% think terrorism should be the top priority. We multiply that by the 24% that did not think that terrorism was a top priority. And then we divide that by our sample size and take the square root. So it turns out our margin of error is plus or minus 2 percentage points. So I take remember, I don't know what my true proportion is. So 7.76 could be above or below it. I'm just going to say, suppose it was below it. Well, if I stretch it out 2 standard deviations, which I'm estimating with my standard error, so if I go down to 0.74 and I go up to 0.78, I'm 95% confident that I have captured this true proportion. So I say I am 95% confident that between 74% and 78% of Americans believe terrorism should be a top priority for Congress and the president. And again, it's that whole idea that 95% of samples will fall within 2 standard deviations. So if I stretch mine out 2 standard deviations, I'm 95% confident that I have captured that true proportion. So let's talk a little bit more about the margin of error. And again, so the margin of error is this quantity right here. How many standard deviations out do I need to go? And then how big is my standard deviation? Again, standard error because I'm estimating. So this is suppose I don't know how many people I should sample. How many is big enough? Well, if I know how many percentage points I want to be within, and I know how confident I want to be, I can figure out about how many people I need to sample. So I solve for n. If I know I want to be within 2 percentage points, and I know I want to be 95% confident, I have no idea actually what my proportions are, so I just say 0.5 times 0.5. That's the biggest we're going to get. Value up here, 0.25. Because, 0.4 times 0.6 would be 0.24. So we just take the middle ground and say 50% success, 50% failure. And then we do some math. Divide both sides by 1.96. Square both sides. Technically, right, I'd have to multiply both sides by n to get n out of the denominator. And then I would have to divide both sides by this. So I'd get n equals my 0.25 divided by that, and it turns out that my sample, I should sample or get responses from 2,401 people. So one proportion, z interval, and z star depends on how confident you want to be. And we don't have a standard deviation. We have to use the standard error, which we get from our sample proportion. So I hope that's helpful. Curiously enough, the Pew, when you dig deeper, said that it was plus or minus 2.9 percentage points. So again, it really depended on, I don't know how they came up with that number, because it depends on which group you were talking about and maybe which question. So there are definitely some details and complexities that we don't cover here, but essentially that's how that whole margin of error business works.